All right, friends, today we are going to continue lesson 6-3. We're going to go through the 3 examples of the lesson, and then we're going to do a bit of classwork. And then at the end of the classwork, you will attempt the Pearson 6-3 Math XL, so the learning that I've been assigning to you through your Pearson portal. So that's going to be ultimately the classwork that must be turned in by the end of the day. Okay, so let's start with our first example. And I've chosen, as opposed to following along with the teacher model of the videos, I'm going to use exactly what's in your textbook so that you and I are looking at exactly the same thing in person. So this is page 348 in your workbook, and this is where I would like you to be right now. Okay, so our essential question at the top of the page is, how can you write a percent greater than 100 or less than 1 as a fraction and as a decimal? So you might think when you first see this, oh, how do I write a percent that represents less than 1? Doesn't every percent, 1 through 99, represent less than 1, 1 whole? What they're actually referring to is less than 1%. So I must say that also, I found that wording to be a little bit misleading. So when they say less than 1, they don't mean less than 100%, less than 1 whole. They mean less than 1%. So how do we represent less than 1%, less than 1/100th? And of course, if you really think about that question, how do we write a fraction or a decimal that represents less than 1/100th? You guys know many ways to write fractions and decimals that represent less than 1/100th. Okay, so that's what we're going to be focusing on for this lesson. Example 1 asks us to write a percent greater than 100 as a fraction and as a decimal. This is fairly similar to the warm-up problem that we just did. It says Jan and Kim built model cars for a science project. Kim's car traveled 140% as far as Jan's car. How can you write 140% as a fraction and as a decimal? So if Kim's car traveled 140% as far as Jan's, whose went farther? Well, of course, Kim's went farther. Kim's went 40/100ths farther, 4/10ths farther, right? 2/5ths farther. So we can say that Kim's car in the red here definitely, in any case, went farther than Jan's car. Jan's car only went 100% of the given distance. So this line here, you can think of it, so from the start to the bumper of this blue car, this is 100% of the distance, okay, that we're calculating Jan's car traveled, and Kim's car traveled 140% of that distance. So here you can see in dotted lines, this is the bumper of Jan's car, and this is the bumper of Kim's car. So this space from here to here represents this extra 40%, this extra 4/10ths. Okay, so how are we going to write it as a fraction? So again, as we went over in the introduction, we're going to put 140 over 100, right? We said percent can be represented as a fraction with a denominator of 100. When we have percents that are greater than 100, that does not change. So even though our numerator is now greater than 100, it's still going to be the numerator over 100. So regardless of how high your numerator gets, if you're talking about percent, 600%, 700%, it's always going to be over 100. So that is the part, the denominator, the second term in the rate does not change in percent. That is the very nature of percent, is that it's out of 100. Okay, so we're going to use division to simplify our fraction. We have 140% equals 140 over 100. We are dividing those numerator and the denominator both by 20. And you might say, where did they get 20? Well, again, if we were, where's my web paint tool? Oh, it's up here. Okay, I'm going to try and see if I can drag that down. So if I were to divide both my numerator and my denominator by 10, so I can just cancel out these zeros here, right? So that would be 14 over 10. So I can also do that here. So then I can divide, let me try and make that a little bit straighter. Okay, so then we can divide by 2, numerator and denominator both by 2. 14 divided by 2 equals 7, 10 divided by 2 equals 5. So 14 over 10, or 140 over 100, equals 7 over 5. So 140% can also be written as 7 over 5. Now, is this fraction in lowest terms? Yes, it is, because the GCF of 7 and 5 is 1. So as long as the GCF of the numerator and the denominator is 1, then that is the fraction represented in lowest terms, and that's as low as we can go. We are going to be talking a little bit in this lesson about complex fractions, which is where you have a fraction that has another fraction in either or both the numerator and the denominator, and that's a little bit trickier. But for right now, we're just going to talk about regular old run-of-the-mill fractions. Okay, so 7/5, this is in lowest terms. 140% can be represented as 7/5. The fraction equivalent of the percent greater than 100 has a numerator greater than the denominator. We talked about that too. Whenever we have a percent greater than 100 that has a value of greater than 100%, that's always going to be an improper fraction, because the numerator is always going to be greater than the denominator, and the denominator is always what? Oh, I heard you all say it's always going to be 100. So if you have higher than 100%, that means your numerator is higher than 100, higher than the denominator. It must be an improper fraction. Right, so when we're talking about greater than 100%, always talking about an improper fraction. Could we turn this into a mixed number? We could. We could say that, what were their names again? We could say that Kim's car went 1 2/5, right, the distance of Jan's car. So we could take 5 out of this. 7 over 5, we could take 5/5 out to make 1. We would have 2/5 left over, so 1 2/5. We could say Kim's car went 1 2/5 the distance of Jan's car. Okay, so there's a lot of different ways to manipulate percent, but we just have to keep in mind when we're writing fractions and decimals, we have to keep our equivalents. So we have to make sure that we're manipulating the numbers in the right way, that they stay equivalent. That is, of course, quite important. So if we're looking at the second section here, let me erase my marks. You can use reasoning or division to write 140% as a decimal. I think this is funny. You can always just use reasoning. Just use reasoning. Just use your mind. So we're going to use reasoning to turn this percent into a decimal. And I'm assuming what they're saying by reasoning is so clearly we know, right? We know that 140% equals 140 divided by 100. And we know when we're dividing by any number, when our divisor is a power of 10, we can just count the zeros in the divisor and then move the decimal place over that number. So if there are 2 zeros in 100, if I'm dividing 140 by 100, I can just move my decimal place 2 places to the left. I'm dividing by 10 to the second, right? And that will give me 1.4. So I assume that's what they're referring to when they're talking about using reason, right? Your knowledge of place value dividing by powers of 10. When you're using a percent, so the denominator is always going to be 100, which means to calculate the percent as a decimal, you can always just move the decimal point 2 places to the left, because you're always dividing by 100. The denominator is always 100. Okay, so whatever I have, 19% over 100, how do I make that a decimal? I just move the decimal place over 2 to the left, because I'm dividing by 100. We have to always remember that even though this fraction is talking about a percent, this fraction is still a division problem. This still represents 140 divided by 100. So that's what they've done over here. They've taken 140, they've taken their numerator, they've made that the dividend, they've taken their denominator, they've made that the divisor. So 140 divided by 100, quotient 1.4, right? We could have just done that by moving the decimal 2 to the left, because that's what we do when we divide by powers of 10. Okay, so this, I just want you guys to, try and keep all these connections. Math is not like these separate bubbles that live completely on their own, right? They're all connected. So things you learned about fractions starting in, 4th and 5th grade and their equivalents to decimals, those things are all connected. Okay, so don't lose sight of the connections while we're moving through. All right, so I want you guys to attempt, let me see if I'll zoom out here. Oh, it's not letting me see it. Well, oh, there we go. Okay, I want you to attempt to try it. I'm going to pause the video. The area of a new Movie theater is 225% of the area of the old theater. What is 225% as a fraction and a decimal? I want you to try that, and I also want you to try to convince me, how would you write 1 and 75/100 as a percent? Give an example in which you would use a percent that is greater than 100. I want you to try both those things, so pause the video, give them a try, and then come back for the answers. Alright, so for our first portion of the try it, to write 225% as a fraction, we would simply write it as 225 over 100. I did go ahead and reduce that to lowest terms, so I knew that the GCF of 225 and 100 was 25, so I divided both the numerator and the denominator by 25. So 225 over 100 is equivalent to 9 over 4. And then again, to write that as a decimal, all I'm going to do is move the decimal place to the left because I'm dividing by 100 because it's a fraction over 100. Okay, so the decimal is going to be 2.25. And what you guys will notice is whenever you have a percent greater than 100, your decimal is going to be greater than 1. So whenever you have greater than 100%, you're going to have at least 1. So 100% equals 1, and then anything over 100% is going to be greater than 1. All right, so how would you write 1 and 75/100 as a percent? 175%. Again, you can go the opposite way. When you're turning a decimal into a percent, it's just like multiplying by 100, so you can move, so 1.75, to make that a percent, we're going to move the decimal 2 to the right, so 175%. And when would you use a percent greater than 100? You could use it to represent growth, right? So we could say when Parker was born, she weighed roughly 7 pounds. She's doubled her weight in the past 6 months, so now she's 200% of her birth weight, right? So we could use that to represent growth. All right, so we're going to turn to the next page. So these last two examples are both discussing how we would write a fraction as, how we would write a percent less than 1, a percent less than 1 as a fraction and decimal. So what is a percent less than 1? It's just anything that is less than 1/100th, right? So if we have a penny is 1% of a dollar, it's 1/100th of a dollar. If we had something that was a value of half a penny, it would be less than 1% of a dollar. It would be half of 1% of a dollar. Okay, so this is just saying how do we represent values that are less than 1/100th? That's really all this is. So if we're looking at this hundredths grid here, the book is saying that we're representing 1/2 of 1% as a fraction. So a 0.5%, 1/2 of 1% as a fraction. And here they're using a complex fraction, which means there's a fraction as a numerator of the fraction. So we have a fraction inside a fraction. So 1/2 over 100. And here they're just writing, right, that this fraction represents a division problem. So 1/2 divided by 100. 1/2 divided by 100, we're going to do, basically they're just saying your keep, switch, flip, right? So we can multiply by the reciprocal of this, which is the same as dividing by the number. We're going to come out with 1 over 200. So 1/2 of 1% can be written as 1 over 200. Okay, and how are we going to write that as a decimal? We'll go through a very similar process. We'll say 1/2 of 1% equals 0.5%, right? You guys know that 1/2 is equivalent to 0.5 as a decimal. So now we have 0.5 over 100. We're going to multiply both the numerator and the denominator by 10 to make the numerator a whole number. So instead of having 0.5, we're going to multiply this by 10 to make it 5. If we multiply the denominator also by 10, we're going to get 1,000. So here they've just written an equivalent fraction that makes the numerator a whole number. So we're multiplying both the numerator and the denominator by 10. So now we're going to have 5 over 1,000, which equals 5 thousandths, right? So just use your knowledge of place value, tenths, hundredths, thousandths. Okay, so moving down here, now we're talking about very, very similar. How do we write 9/10% as a fraction? So 9/10 of 1%. You're just going to follow the examples here. These are very similar to what was being done in the last problem. Okay, and that's pretty much that. We're going to move over to the classwork. I'm posting the answers to the classwork here. So this is on page 350. This is what I want you to do, and then come back and check the answers. So here are the answers once you're finished. When you're done with this, I want you to head on over to your Pearson portal and complete the digital classwork for today. All right, so once you've done this, you've checked your answers, you've done the digital work and submitted it, you are done for today. All right, I will see you guys tomorrow. Please email me with any questions.